Hi everyone, welcome back to the Microsoft in 29 days series. In case if you have not registered yourself for the Microsoft in 29 days series course, so you can find the link of the course in the description. Once you register for this course, then what you can get is you can get the access to this course where if you let's say click to day 6, then you will get the recordings of the problems of day 6 individually. Apart from this, you will also get the access to the practice problems. So here, as you can see, multiply strings, alien dictionary, and every problem along with the topic tag and the company tag has been given to you. So you can try this out. Now let us discuss the problem, painter's partition. So the problem is that Dilpreet wants to paint his dog's home that has n boards with different lengths. Okay, so basically there are n boards and all of them are of different length. So it will be denoted by an array, okay, which will have n number of indexes. Now in this case they are saying that the length of the ith board is array 5. Okay, so for the ith board the length is array 5, and it says that k painters are hired for doing this work. Okay, so k painters are hired for doing this work, and now each painter takes 1 unit of time to paint the board. Okay, so every painter takes 1 unit of time to paint 1 unit of board. So suppose if there is 60, the length is 60. Okay, so if there is the length is 60 units of board, then the time taken will be nothing but 60 units, right? So that is the thing. So basically for 1 unit 1 second. Now if in this part you observe, so the problem says that we have to find the minimum time in which the job can be done. Okay, so we have to do what? We have to find the minimum time in which this job can be done. Okay, of painting. So we are given the constraint that this job is done if all the painters start together with constraint that any painter will not paint will paint only contiguous segment, right? So if the painter will has painted 10 here, then it will not happen that painter 2 paints and then painter 1 is also painting some segment. It will not happen, right? We basically painter 1 like every painter will paint the contiguous segments. So we need to do what? We basically need to find the minimum time in which we can do this. So like let us take some sample examples. So let us take this example where what we have been given is we have been given let's say 10, 20, 30 and 40. Okay, so if we have been given this example, like let's say we have been given 10, 20, 30 and 40. Suppose we have been given 10, 20, 30 and 40. So suppose if this job was to be done by one painter. Okay, so if one painter does this job, so the total sum is what? Total sum is nothing but 10 plus 20 plus 30. That comes like total sum is 100. So if just one painter did this job, then 100 unit of time will be taken. But suppose if four painters do this job. Okay, suppose if four painters do this job, then how much time will be taken? If painter 1 does this job, painter 2 does this job, painter 3 does this job, and then painter 4 does this job. So the maximum time taken will be nothing but by the painter 4. Okay, so if all the n parts have to be painted by different painters, like if all for the different parts you apply 4 different painters, then even the lowest time that will be taken will be nothing but the maximum element of the array. Okay, this will be the lowest time that will be taken. That is nothing but the maximum element of the array. If n painters are assigned then, and what is the highest time taken? So if just single painter is painting that, then the highest time will be nothing but the sum of the all the array elements, right? This will be the case here. So we have to do what? We have to find the minimum time. So now if we see here, so we know that the lowest will be nothing but the maximum element of the array 5 when all the n different painters are painting. Even then the maximum element of the array will be the maximum time, like maximum time, lowest time taken. Now high is what? High is the sum of all elements, right? Sum of all elements. Now high is when we just assign a single painter to paint it. Now in if we observe, so what we can do is we can try and apply a binary search here, and we can calculate the low as nothing but high plus low plus high divided by 2. And once we have calculated the mid, so we can check that if low is the low unit of time and high unit of time is there, so if till mid unit of time whether or not k painters, like if in k units of time, if I can use at most k painters, if I can use k painters, I can paint it or not. Suppose at a like suppose till mid time I can paint it, right? Suppose till mid period of time if the painters can paint it. Okay, So in that case, what will happen? I'll try to search in the left side. So I'll say that what, like if till mid, I can paint it if it is feasible for me to paint till mid period of time. So I'll try to change my bias towards the left side, and I'll say that high is equal to mid minus one. Otherwise, if till mid period of time I cannot paint it using k number of painters. If I need more than k painters for mid unit of time, then I'll try to change my bias search towards the right side. So low will become what, high plus, or like low will become nothing but mid plus one. So that is what is going to happen here. So basically for this, for every mid, we can try to write a check function whereby we can check whether that particular till that particular mid time it is possible for painting the fence with the given array or not. Okay, that is what we can do. So that will be the approach overall. So what we'll be first of all doing is we'll be given this function in which we have to return the minimum time. So first of all, we'll have the low and we'll have the high. So initially we'll mark the low and the high as 0, and low will be what? Low will be the maximum element of the array. So we'll iterate through the array like int I starts from 0, I is lesser than n, and then I plus plus. And what is the low? So low is equal to nothing but the maximum element, maximum of low, and I can mark it as, let's say, long. I can mark it as, let's say, int. Okay. So like low will be what? Low will be nothing but the maximum element among low and the array file. Okay. So low will be nothing but the maximum element of the array if all the painters are painting. And similarly, we can say that high will be what? High will be nothing but the sum of all the like high will be sum of all the elements of the array. Because suppose if just one painter is painting, then the time taken will be the sum of all the elements of the array, right? And after this part is done, so what we can say is that we can maybe mark the answer initially as -1, indicating that it's not possible. After that, we will apply a bind search. So we'll say that low is lesser equal to high. Till then, we can keep on doing the bind search, and then we say that mid is equal to nothing but low plus high divided by 2. So first of all, we calculate the mid, and then we need to check that whether with this mid, if the answer is possible or not. So we write a check function here. Okay, we write a check function here where we will do what? We will pass an array. Okay, we will pass the n, and we will pass the mid, right, till mid number of hours it is possible or not, and k, I'll pass the k as well, k number of painters. So if this is possible, right, if till mid number of hours is possible, then I will mark that okay, this mid is my answer. And what we will further do is we will try to search in the left side. We will try to find that whether if this till this mid number of hours, if I can paint the fence with the k painters at most. So I'll try to check that whether I can reduce the time or not. So I'll say that high is equal to nothing but mid minus 1, so that I can change my search space towards the left side and find a better answer, a much more minimum answer. Otherwise, if till this mid I cannot paint it using k number of painters, so I'll change my bind search towards the right side. So I'll say that low is equal to nothing but mid plus 1. Okay, this is how I'll apply the bind search. And after the bind search has been applied, so we can simply do what? Say we can simply return the answer part here. And after this part is done, so we will write a check function. So the check function will be of boolean type. So let's say we write it as check, boolean check, and then we will pass the array here, and we will pass the number of elements as n. Okay, number of elements in the array as n. We'll pass the current mid. Okay, so we will see whether this till this current mid it is possible to do it or not. And another thing that we'll pass is we'll pass the k value, that is the number of painters. And then in this part, what we can say is that initially we'll start with one painter. Okay, and we will see like every painter's capacity here is mid. If the painter's capacity, like every painter will do the job till mid hour, right? So basically what is happening, if I have a particular mid, right, I want to see whether till mid till mid number of time, mid unit of time, whether the task can be done or not. So whatever number of painters I have, every painter will maximum work till mid unit of time. Okay, so if a particular painter paints and he has already done the work till mid unit of time, then I will apply I will, like, suppose painter has done the part till mid unit of time, then I will allow a new painter, right? I'll say that okay, I need one more painter to do this job. Suppose the painter 2 also does the task till mid units of time, then after that I'll not do further task with painter 2. I'll have a painter 3. I'll have a new painter, and the painter 3 will also do the task, do the painting till mid hours, right? That is what will happen. So in this case, what we can say is that initially I'll go with one painter, and initially I'll mark the sum as 0. Like basically the work, I'll say that work is 0 for the current painter. Okay, and then simply like we can say like since we are taking the sum, so we can take it as long, and then what we will do is we will say that int I starts from 0. So we will start for all the walls or all the fences that are there, and we will say that if the current painter's capacity, so if the sum, that is the work that the current painter has done up till now, plus the current work that he wants to do, if it is still inside the mid range, if it is still lesser than equal to mid unit of time, that means that the painter can do this task. And if we can do this, so I'll say that sum plus is equal to what? Sum plus is equal to array 5, because I'll add this much number of hours of works to the current painter. Otherwise, if the current painter cannot do the task, so I need one more painter. So I'll say the painter plus plus, and I need to reset the work time. So I'll say that sum is equal to, or work is equal to array 5, because the new painter is doing it. So the current work that the new painter will do is nothing but array 5, and after that I'll iterate for the next value again. And after this part is done, so we need to check what? We need to check that if the painter, if the number of painters is lesser equal to k. So if I'm able to, if till this mid number of mid unit of time, if every painter is able to do the job, and the number of painters that I require, if I can paint the fence, and if I painted the fence and the number of painters that I have taken for doing this job is lesser than equal to k, then I can simply return true, indicating that till this mid unit of time the work can be done. Okay, and if till this mid unit of time the work can be done, so my bind search will shift to the left side. Okay, so my high will become mid minus 1. Otherwise, I will return a false, indicating that if k number of painters, if I require more than k number of painters, so I will change my bind search towards the right side, and for that low will be mid plus 1. Okay, now let us try and compile this code. Okay, so we are getting a compilation error here. So it is saying that long and int. Okay, so I have taken this as long, so I should take this as long, right? Now let us try and compile this. Seems to work on the samples. Let us try and submit this code as well to see if it can work on the problem. Yeah, so I think it will get accepted. So you can see that our solution was able to pass all the test cases. Now you can see this problem has been asked in Google, Microsoft, and Codenation, and many other companies, talking about the time complexity of this code. So in this code, if you will see, so what is happening? Like if you apply binary search for one time, okay. Suppose that you apply for binary search for one time. So it will be what? Log. It will be nothing but log of you can say m, where m is what? M is the sum of the all the length, right? Where like you can say what? You can say that it will be like sum. It will be sum of all the fences, right? And if we apply, like if we apply it for one time, but we are applying it every time, and we are applying it like if we do the normal binary search, it takes log n time. But when we like it is normal binary search, but we have n different indexes, right? We are iterating again. If you see in the function check function, so we are iterating again and again every time, right? For n number of times we are trying to iterate to the array for a particular bit. So that means n log m will be the time complexity of our code. Thank you. In this video, we will discuss the problem leftmost and rightmost index. The problem says that we have been given a sorted array with possibly duplicate numbers. So in this given array, there are duplicate numbers, right? Let us suppose that if we have been given an array which is sorted, so a sorted array which is duplicate. So let's take an example like 2, 4, 4, 5, 7, 7, and 9. So you can see that if I write these elements, so 4 is duplicate and 7 is also duplicate. So if suppose that I want to find 4, so I like here also 4 is present, here also 4 is present. So I need to find, let's say, the leftmost occurrence of 4. So in that case I will return this occurrence. Similarly, if I want to return the rightmost occurrence or leftmost occurrence of 7, so I'll return this occurrence. And in the same way, suppose that the array is 1, 2, 2, 2, then 3, then 4, 4, 4, and then 5 and 5. And I want to find the rightmost occurrence. Okay, if I want to find the rightmost occurrence, so in that case, this will be the answer. Okay, and this index will be the answer, and this index will be index will be the answer for 2. If I'm finding the rightmost index of 2, if I'm finding the rightmost index of 4, so this will be the answer. If I'm finding the rightmost index of 5, so this will be the answer. Okay, so that is what they are expecting from me. So this problem is a little bit different from the normal binary search, where what we do is, if we talk about the normal binary search, okay, so talking about the normal binary search, so let us say that we have been given a particular number, right? So we first of all calculate the mid based on the low and the high. Okay, we calculate the mid and then we check. Okay, what we check is that if array of mid, okay, if the mid element is lesser than the if the mid element is lesser than the key element that I am trying to find. So in that case, what I do is I try to change my search space towards the right side, because if element at the mid index is lesser than the key, then all the elements towards the left of the mid, that is all the elements from low till mid minus 1, will also be lesser than the key, right? So in that case, I need to change my search space from the right side. That is what I need to do is I need to say that starting from mid plus 1 till the high, I need to do my searching, right? So that is what I would do. So here in that this cases, what we do is we say that high is equal to nothing but mid minus 1, okay? And otherwise, suppose that else if what happens is if a of mid becomes greater than the key. So if the middle element is greater than the key, then that means all the elements towards the right side of mid will also be greater than the key, right? If mid is greater than the key, if element at the mid index is greater than key, then element at the index mid plus 1, okay, will also be greater than the key, right? And so on. So therefore, if I want to search for an element which is equal to the key, so I need to search towards the left side of mid. So that means this means what? This means like in this case, if my mid was greater, so like if this was the case, so I'll say that like if a of mid is lesser than the key, right? So in that case, I need to change my search space towards the right side. So low is equal to mid plus 1. Sorry. And here in this case, if I want to search towards the left side, so high is equal to nothing but min minus 1. Okay, these two cases are clear. But what if the element is the same, right? So sorry for writing this, but now let's see what will happen. So otherwise, what happens? Like let's say else if it happens that the current mid element is equal to the key, right? If even if it is equal to the key, in that case, where do I want to search? I want to search like I want to if I want to find the leftmost occurrence, right? So in that case, I want to search towards the left side again, because I will say what I will say that answer is equal to nothing but mid, but still I want to search in the left side that whether or not there is a mid index present, such that at this particular mid index I can like at whether or not I can search like if at a like let's say what I do is I have 5 5 and 5. So if suppose this is my mid, okay, this is where my mid is standing, and at this particular mid index I'm getting this particular element, okay, 5, but I need to search in the left side, okay. So that is why I will say that like again high is equal to mid minus 1 basically. So I will change my search space from low till mid minus 1, so that I can find a lesser index at which the same element is present. So that means the leftmost index, the least index, the leftmost index at which the key element that I want to find is present. So in that case, I change my high to mid minus 1 and check if it is present. Otherwise, whatever is stored in the answer, I'll simply return it. And now, so if I talk about the rightmost occurrence, okay. So what happens here? So if we say that array of mid here becomes the key, if it's equal to the key, okay. So suppose 5 5 5 was there, and if this particular mid value was I was finding and it was equal to the key. So in this case, what I would do is I would say that my answer is equal to this mid index, but since I want to search in the right side, so I'll change my low to mid plus 1. Okay, that is what I would do. Otherwise, suppose that what happens is else if it happens that the mid element is lesser than the key. If the mid element is lesser than the key, in that case low is equal to nothing but mid plus 1. Okay. Otherwise, if it happens that else if it happens that the mid element is greater than the if it's greater than the key, right? If the r of mid is greater than the key, so in that case what I need to say is that in this case what I need to do is I need to say that high is equal to mid minus 1, because I need to search towards the left side. So that is what I would do here, and I will simply store the leftmost index of the given element and the rightmost element index of the given element, and then I'll simply return the answer. So this is what we would do. So let's try and write the code for it. So basically we have been given a sorted array. So what we will require is we will require a pair of long comma long. Okay, let's name this pair as p, and let us initialize this pair as minus 1 comma minus 1. Okay, indicating that currently the answer is not possible. And after this part is done, so what we will do is like I will have int low is equal to 0 and high is equal to nothing but n minus 1, or you can say v dot size minus 1. And after this part, you simply check that while the low is lesser equal to high, if it is, then what I do is I apply the by search. So I'll say that int mid is equal to nothing but low plus high divided by 2. Okay, and then once this part is done, so what we check is we check that if it happens that v of the mid, if the mid element is equal to the x value that I was searching for, if it's equal to the key, in that case I will store the answer. So I can have an answer like int answer, I can have a variable as answer, uh, not answer. Basically, I don't need an answer. I can say that p dot first will indicate me the leftmost. So the first part of the pair will tell me about the leftmost. I can say that p dot first is equal to the current mid. And then since I want to search towards the left side, so in that case I change my high to nothing but mid minus one, because I want to search in the left side. Otherwise here what I do is I need to say that else if the current mid is lesser than x, right? If it is lesser than x, then what will I do? I'll say that low is equal to nothing but mid plus 1. I need to search in the right side. Okay. And otherwise, suppose in the else part, if the current mid element is greater than x, in that case I need to search towards the left side. So high is equal to nothing but mid minus 1. That is what I would do. Okay, that is how it will get stored. And now again I will update my low to 0 and my high to nothing but b dot size minus 1 again. And then while the low is lesser equal to the high, so what I would do here is while the low is lesser equal to high, and again apply the bind search for finding the rightmost occurrence of the same given element x. So mid is equal to nothing but low plus high divided by 2. After I have calculated the mid, so what I will do here is I will say that if the mid element is equal to x, if it is present at this index x only. So in that case, what I need to do is if it is present at this index x only, so in that case I need to say that this will be stored in the answer. So p dot second is equal to nothing but mid. But since I want to find the rightmost occurrence, so I'll change my search space towards the right side. So low is equal to nothing but mid plus 1. Okay. Otherwise, else if it happens that the v of mid, okay, if the v of mid is lesser than x, in that case again I need to say that low is equal to nothing but mid plus 1, because I need to search towards the right side. And otherwise, if it happens that the current mid value is greater than x, in that case we will say that high is equal to nothing but mid minus 1, because we need to change our search space from low to mid minus 1. Okay, that is what we would do. And since it is stored in the answer, so I can set directly return this pair, that is nothing but p. So now let us try and see if it can get compiled here. Okay, so we are getting the same output. Let us try and submit this code as well. So you can see that our solution was able to pass all the test cases. Now talking about the time complexity of this code. Okay, so since we are applying a bind search, so the time complexity would be nothing but order of log n, and we are not using any extra data structure or anything. So that's why the space complexity would be nothing but constant space, that is order of 1. And let us discuss about some of the practice problems for this day. So the first practice problem that I am going to give you is the first and the last occurrence of x. It is a basic problem, and it has been asked in some of the companies as well. If you see, it has been asked in Amazon and Microsoft. Then the next problem is a medium problem, that is capacity to ship the packets within d days. So you will be given an array and you'll be given n weights, and you have to find the least weight capacity of a boat to ship all the weight within d days. So that is the problem, and this problem also has been asked in companies like, you can say, it has been asked in Disho and Amazon. Then the last problem is pretty standard problem. Median in a row wise sorted matrix. Will be given a matrix which is row wise sorted, and you have to apply you have to find the median. So in this you can use the concept of binary search, because the row wise sorted matrix has been given to you. Thank you.